Every day, people walk around without having to think about how they're walking. But for amputees, it's a different story. They use more energy in walking, fall more frequently, and have to adapt to their passive prosthetic leg, which has no knowledge of what the amputee is doing. However, if they had a powered prosthesis, we could use motors and a battery to make the prosthesis move on its own and give energy back to the user. To control powered prostheses, math is required to determine how much power to give the motors to move as desired. Current mathematical methods for prostheses rely on tuning a large number of values by trial and error for every patient, which is very time-consuming. In my research, I developed a method for prostheses that requires less tuning, instantaneously adapts to the human, and mathematically guarantees safety for the prosthesis. As a starting point, I use methods developed in my lab to successfully make robots walk like people. Now, we can't directly use these methods on a prosthesis because we don't know what the human is doing the way we know what every part of a robot is doing. I address this limitation by theoretically proving we can control prostheses as well as if we knew what the whole human was doing by incorporating a force sensor, a rotation sensor, and a pressure sensor. The force sensor and rotation sensor completely capture the human's effect on the prosthesis. The weight of the human and the orientation of the prosthesis affect how much power the prosthesis needs to achieve a desired motion. This is similar to in driving. The weight of a truck and the steepness of a hill affect how much gas the truck needs to drive the speed limit. Now we can directly measure the effect of the human instead of tuning numbers for every person. These sensors also give us enough information to precisely compute how much power to give the motors to follow a safe walking motion. The third sensor is a pressure sensor inside the shoe of a human. It acts like a remote control for the prosthesis. This sensor detects how far the human is leaning forward based on where the highest pressure is on the foot. The prosthesis can synchronize its motion to swing at the same speed the high pressure point moves across the foot. Developing and implementing these mathematical methods is a first step to creating prostheses that detect the human's behavior. So amputees don't have to adapt to their prosthesis, but the prosthesis adapts to them. So amputees can walk without thinking. Thank you.